Hey everybody. So today we're actually on the verge of completing this whole project and tell you let's discard everything we've got there. See. We want the query string. Let's take it as a string. Then we also want the type. Selected type metadata. We can have a string for now, but this could be a token string. Then we also need, what else could we need? Interpolated variables. Interpolated. So let's take that for this also. So basically this is all we need. Let's call this selection metadata. So let's say we've got a function called select user. And the idea is you can create a query as, let's say, you should be able to do something like maybe select infer the return type. Let's say the return type is user and the query is actually let's run out query macro. So we've got this. Okay, this got interpolated variable. So will look like this, and so we need the return type, which will be generated. We need the query, and within, can I close this now? I'll just minimize. Let's minimize it for now. So I'm gonna need that. Then, but that's a query statement. Actually, would be more interested in a select statement. Tell you what, let's go to the website. SurrealDB. Let's go to queries. Go to statement. Select. See, I'm just gonna copy this so I don't have to go back and forth like a ball on a tennis court. So I'm just gonna copy this out because this is more relevant for the select statement. I'm just gonna take that. Let's put that somewhere. Select statement doc. Let's put it as an empty. Okay, so this way we can have it to the side and reference that. So if we're trying to do something, let's check one of these. Maybe something more concrete and valuable with references and all that. A little bit more complex. I'll take this first. That's good. And case index comes a little bit more complexity. And okay, let's take that also. Let's take that. Another example. Different. I mean, with great power comes great responsibility. Oh, what the heck? What's that? So because you have all this flexibility, it actually comes with a lot of okay. Yep, so let's take one of these, for example. This can generate something like Tanya says struct user name. Yeah, so if we could generate something like that. But if we got, or if we got this in addition to that, we might um mm, mm, mm. maybe we could do something like person and person button. So we select another field. Then every other thing is just an addition override. But first I need to be sure. And of course, Friday. we could do something like that. But if we could have multiple of that might be problematic, and we can test our hypothesis. Okay, my intelligence here. So what am I going out here? Maybe we could import. We can actually try it here, but okay, it seems to be awake now. Copilot seems to be getting away. Copilot, stop. Anywho, and of course, this could also be getting in the way. Import serialize. User what's up? So that's kind of interesting to me, because this should flatten the object, and I would have expected like a sort of like collision error, but maybe because we don't have deserialize implemented, because that matters more when you're deserializing. Okay, if that's the case, that might actually work to our advantage. So this is where how do I go back? Here. To string. What? So it actually serialized it. But that is insane. That is weird. It's cool. It's beautiful. I love it. let's say select all from actually just from person, then in that case this could just be using it for it could generate something like this. Yeah, and that would yield the same result if you do something. Of course, if you have something like this, you probably should be using the query builder, like the ORM functionality, or just the basic query, since this is quite straightforward. But I think this is actually a good way to go. Let's test something like this. How many data is empty? So let's check the Explorer. User 1 and on person 1, person 100, and maybe we check person 1. Okay, this is probably not a good idea for you to do in production, except you just want to do some aggregation. And in this case, you should probably just do everything manually. Just trying to okay, I think I'm starting to have clarity around what I want to achieve. Good, that's the type. But then we might have things like interpolation. So this might be influencer. In that case, we would want to generate we could even use this generator struct, which takes the return type. So it could be something like user it already has a query, and now me just take the string of file version of that, or I'm trying to just think through if this benefit is if the benefits are worth the while. think I have clarity around what I want to do now. Right, so I think I pretty much have everything in place to get this going and working. I just need to put them together. So we've got the query with the string itself. We've got the variable interpolation and the returned results. Those are the three key ingredients. So by default, we're going to be using the field names. And when you're having a complex field name with anything other than a snake case, like normal character, UTF-8, uh, 8 character without the hyphen and all this other strange stuff. Basically, snake case, anything other than snake case, it's gonna prompt you to alias that, and we are going to be providing a more generic type for all the field names. So somewhat like a Saturday value, Saturday JSON value, which could be anything. It could be any value. However, if you want a more specific type, you can just specify that you can say these coordinates field or coordinate alias has to be an integer or a string or even a more complex type, as long as it implements serialize and deserialize. Um, yep, I think that's pretty much it. And of course, anytime you've got asterisk also, we're just gonna tell you to, we're also gonna default to a Saturday value and just flatten that on the entire struct. But we're gonna prompt you perhaps to specify the type, the node type or the edge type, model type. So that's essentially what I'm gonna be doing now. Um, yep, yep. So I just implement that. I don't know. I need to muster the energy to continue this stream. Let's see. Hey, easy. just thinking if this is actually even worth. I'm not convinced yet that this is actually worth it. Now that I'm looking at the entire API, because with this, it seems like you're getting worst of both worlds. Like you're implementing, I'm gonna implement this new API, which is additional stuff for you to learn. Then the second thing is this, while it's gonna do some type checking and stuff, I I don't believe it offers much, and I can only see you needing this when you're having a select query. You can add you can make the argument that you don't want to type things out, but I don't think that should be an excuse at all. Like you're typing a lot less than you're reading, and a lot less than you're consuming. So what's the worst case? Your field is gonna have like 100 fields. The vast majority of time, you're gonna be calling dot select or dot get, and I can see that working for probably 90% of your cases, or even like 99%, because with the way this database library is set up, you can have a struct like a class. Now I can show an example. So on this table, which is called spaceship right now, right? You can you can have a link. I'm not sure if I have it in the README yet, but at least it's in the uh, it's in the test. Okay, let's check it in my let's check alien, for example. Alien, right? So here we can define different fields, define the relation to the same struct, that's the self-referential stuff, define a foreign table, which is a one-to-one relationship, define many, and even have a many-to-many kind of relationship. So this probably accounts for the vast majority of things you want to do. If you want to select like multiple stuff, you want to have like nested selection, this is going to cater to most of your cases. And after your deserialization, worst case, if you let's say you want to select subfields, you can select a subset of that once you get your data out, right? And in the few cases where you're gonna be having like aggregation with different function operators and stuff, I don't think it should be that big of a deal to type out the struct you want to deserialize out, because I can definitely implement this. I already have the API for this. I think if I spend like an hour to two, I should be able to complete the implementation for this. But the more I am fleshing out the API, the less convinced I am that it's actually going to be worthwhile to have this. Because I mean, yeah, you can have things like count, blah. Let's say you have an array function that does maybe array sum. Let's say we're summing the coordinates, then you have the alias. But in my case, why wouldn't I just want to type out a struct and say some selection? And especially these days I use Copilot, just type it out, name, and I can very more strictly just say this is a string. I believe the new stuff that I'm even trying to implement might encourage bad practices, and I'm creating this stuff for myself first. So I need to, as much as of course I need to cater to the community, but you can't just keep implementing everything because it's possible and doable, even when the benefit might not be worth it. So maybe this sum now is just this. Why wouldn't, even if I've got 100 fields, like most of the time when when you've written out the code for the selection, you're not doing that every time, right? I don't believe that's a big of a reason, right? And because of the way Rust works, when you're trying to deserialize into this, if one of your selections is invalid, if the type or the field names don't align, then you're gonna get a runtime error anyway. So for the minor edge cases, the few scenarios where you need to type more complex aggregated query, this should solve for your stuff, right? Um, so, and if I don't want to take the route that the SQLX is taking also, because you having to set up a live database to cache some metadata and always having to set some extra parameters, run some CLI through your code base. I'm struggling to I'm struggling to see how the cost outweigh the benefits. So this is something I might put in the issue, just put out the API. Even in the future, as things evolve more, if this becomes clearer that it will offer some benefits, then I might add it. But right now, adding it would just be an unnecessary additional bloat to the code base. Yeah. And I'm still, as I'm speaking, I'm still thinking things through and trying to make some form of justification for this. But it's kind of hard, even for the peak and omit that I was planning to do. Like maybe I might still do the peak. That seemed to be even might seem to be a bit more valuable. So I might actually implement the peak stuff, maybe in the other PR. But this right now doesn't seem worth it. But at least I have the API, I have clarity around what I might be implementing if and when I have to ever do that. So let's see. Select. I'm just gonna put this as a comment. The API might look like this. Yep, something like that. Actually, one more thing. This would be, of course, you, I believe, await that. Then you unwrap it. then you take and then wrap this again, this more, then this could take self, that's at least takes user, and you can return user or data, whatever it is here. So in this case this would be user. Yeah. After thinking, weighing the cost and benefit of this, I am not yet convinced that it is worth it, considering that the current APIs cover probably 99% of use cases. I think there are a lot of edge cases if you have to create super complex query application. That's then also a lot of edge cases. That was the other reason in my mind. The edge cases and the frequency of uses as in this is almost exclusively used in read operations, which does or should at least should not mutate the database. So even if you make mistakes and get runtime issues, shouldn't be much of a big deal. I should probably include examples here, but I'm too tired to I'm too tired to do that. Or lazy. So yeah, I might implement the peak. For these, I'm not very like I'm not convinced that it's worth it. I mean, it can help you check that you're actually having the right aliases and stuff. But oh, let me give this a bit of thought before I move on to something else. Two hours ago. Okay, I don't open that. So and if hey yo Sack, what's good? Yo brother, what's good? Where you chatting from? How did they find the channel? I was just thinking through the feature I'm planning to implement now. If you've been watching, do you use Rust? How did you get interested in Rust? So maybe if I type this out, it might actually be helpful. Let's see if I've got something like this above here. What's up? What's up? Where are you chatting from? We've got something like this. So I say you do something like this. I mean, this checks that you are. I don't do Rust. I do Linux cybersecurity and some shit. Oh, that's dope. That is cool. But are you interested in Rust at all? How did you find the channel also? Python, Bash, C++. That's some dope ass combination. C++ is brutal. I'm actually looking to start working with Zig, but just like some hobby stuff. I'm not gonna use it in my major project, except I really, really have to. I like the fact that two things I really love about Zig is the fact that you can just directly operate with C. You don't even have to FFI. I love that. And I also love the fact that you have introspection. Like when you're working with Rust, you're doing metaprogramming in Rust, it's a lot more complex because you're basically working with the syntax tree with the tokens and stuff. But Zig, you seem to have much more control, like as though you're writing normal like code as you would. So I love those two things, especially being able to interpret with C very flexibly and fluidly, and also metaprogramming is a lot more pretty much straightforward. It doesn't even feel like you're doing something else. But metaprogramming in Rust is a different beast. Also electronics, ASM, that's cool. No small bits and physics. Oh, I love physics. We're trying to build a quantum computer, trying to do the ropes. That's fucking cool. I love physics. I've always loved physics and math since I was little, and I still recommend if anyone is interested in even in computer science today. If I would be doing things all over again today, I would I would definitely do physics or maths, maybe physics over computer science. I would probably major in physics, then have a minor in computer science and mathematics. That's what I would do, or something like engineering, something very math heavy. I wouldn't do computer science as my major today because physics just gives you, if you can leverage things properly, I think physics gives you a lot more opportunity, like flexibility, because it prepares you. I mean, if you really pay attention in school, it prepares you the best for real world, in my opinion, because you learn to learn a lot. You learn really about very applicable skills, um, and your problem solving would just be like way better. About Rust, I haven't seen a tool called RustScan. I've seen a tool called RustScan, which scans IP and scans ports. Yeah, but Rust I have only seen good documentation. Maybe one day I will learn that shit. I mean, yeah, there's no rush. It took it took a few years after I learned about Rust, not maybe a lot, before I started learning Rust myself. And it's kind of interesting. When I actually started learning Rust, the plan wasn't even to learn Rust. I was just so sick of JavaScript at this point. I was tired of not being able to write a proper multi-threaded lang- program in JavaScript, not being able to take advantage of the CPUs and parallel processing. And of course, I know there are web workers, but it's not really the same. And I was tired of that. I was tired of the fragmentation in the ecosystem, just a lot of stuff. TypeScript, the build tools, just so much hassle, the package manager. So I was looking for something fresh, and this time I had already worked with maybe like 9 languages. With Java, I just didn't want to deal with JVM and the garbage collector tuning and all that. I've worked with that. I've had experience with that. Um, with Ruby, lack of types. With Python, lack of typing. With R, lack of typing, and of course R is more like scientific language. Golang was the only. Elixir also didn't, at least as at then, they didn't have good LSP. I didn't like that. Haskell was kind of like niche. Um, Elm was most also very niche, very front end, and also very fragmented, very sparse ecosystem. So pretty much I was PHP also not properly typed, and I couldn't do proper multi-threading. And of course, I know in Node.js you can write your program, or in Python you can use Cython and just write your program in C and just bind them. I was like, no, I would rather just do like use a proper programming language. I don't mind learning, even if it takes me like 10 years to learn. as long as it's gonna serve me well. Recommendations didn't mean document. Oh, I see. All right, it's nice meeting you. I hope you have a wonderful one, and thanks for checking in. So I'm just thinking through this and trying to weigh the cost and benefits and thinking through if this would be worth it. And as far as I can see this, it doesn't really cut down as much duplication. So we can write the pros. We can have the cons. Can probably pop it in the GitHub link. We can infer not. We can infer the. We can infer the return type field name from the. Not even infer. We can check validate or check the return type field names against what was selected query. Those are the two main things I can think. Cons. One that I can think of is defaulting field every field type to issue. I think this can also be a con. I mean a pro. We'll add it. Can progress but it does not provide much utility. Sharing Yeah, so that's another con. One more thing to learn. This can be eased up a little. Additional meta overhead. One more thing to learn. Defaulting every grade. So I'm thinking in terms of the ergonomics. So this one is more about the ergonomics, and this is more about the cognitive overload. So the big value proposition that I can really think of, and like this, where was that? This caveat rebuttal. We can also achieve this by just returning error server. Yeah, I think this has most of the arguments, and for me, the main value proposition I can see, in fact the only value proposition I can see, is that these field these field names, the selected field names, are actually checked, so can potentially be checked. So you say this is person, and you're expecting name, but this is AME. This can throw an error at compile time. That's really the only value proposition, and that's not entirely useless. But in what case are we going to need that? If you need to import that on the client and use that, but that's going to give you a value rather than a string, so you really can't do much to it with it. You're probably going to have to be downcasting that, and or maybe making a pattern matching to check that if this is string. So I think uh, considering all these gotchas, edge cases, overhead, and everything, these doesn't seem to be worthwhile to me. So I'm gonna add this additional argument. Now this is a select query anyways, and I'm just gonna edit that. Let's just copy this. I think having the pick macro might be more beneficial in my opinion, so that at least you can pick, you can make a subset of whatever you need from different struct. But this is not what's right. I'm sure, like, I can look into how SQLX does achieve their stuff, and we can probably do something similar. But I'm still not convinced, considering what this framework already offers. I'm not convinced yet that, at least for now, that it's worth it to do all this gymnastic and implement all this feature. The only way I can really see this being feasible, and this is given the constraint of Rust, right? Like when you're really doing macros, they are not, and at this point I think I'd like to think that I'm fairly fairly experienced with the old macro system, and so I've already seen the limitation. So macros are very powerful, but really they aren't very special in the sense that they don't tell you more than you can see. So what you see is what you get. And the way I can really see us achieving this in a way that is robust, predictable, deterministic, and ergonomic at the same time is if we, for example, get some kind of metadata from SurrealDB, we run all our um, migration sort of, so we get the existing schema from the database, so we get all this metadata from the database, and we can use, let's say, the in-memory, or we can cache this as a file, local file database. That's also another possibility. Then from that we can parse the information about the different tables and different fields, their types and stuff, and create a kind of like graph. This is already a graph, so we create a kind of knowledge graph. And when we are implementing the select query, we can just sort of like traverse the graph for every field you select. For when you select name, we can look into the database that, okay, where is name coming from? It's coming from a person, or go to person, check the field name and check the type. And we can just, okay, type is database string, then we can map that to raw string. Or it's date time, we map that to raw date time. It's geometry, we can map it to a more generic geometry, or whatever is declared in the database, right? So the trade-off with this is that now you can't use a schemaless you can't use a schemaless approach, but we can also support it, since every struct you implement node trait for, or edge trait, we automatically generate the type for them anyway. So that's probably not a big concern. um, but I'm thinking more in terms of the ergonomics regarding surrounding the infrastructure, like setting up the, even if it's live, or I mean in memory database or file based, how is the workflow gonna fit into this? Then are we going to be parsing the code base to get the metadata about different tables, or are we going to tell you to create a separate crate and then um, run all the migration so that we can get the current state of the database, so we can parse the metadata about the tables and the fields from which we build the knowledge graph to get the types and make the inference from the type. So given all these, I think it's definitely, I can see some feasibility. I thinking from first principles, I wouldn't see why this wouldn't be feasible, but this would require a bit more thought, for if we to get something that would be much more magical and just do everything. I think it requires a little bit more thought, because SurrealDB, and the alternative route I could take is that I can impose some constraint on the user that now this only works if you're doing high level selection. So basically you're just selecting simple field, name, age, class, and you're not doing, like in SurrealDB, let's see, I think I've got this stuff that you can really have some nasty complex queries. So let's see an example. How are we gonna do this? I mean, if we're using a graph, right? When we access this artist and we see that it's on review table, we can parse the graph and see that is this an embedded thing, or do we have to reference a destination table, like a foreign table. And same goes, let's see, but what happens in this kind of scenario? Oh, you're using math mean. If you're using math mean, that's a mathematical operation, and we can tell you that you have to alias this. But if it's a mathematical operation, we can infer that this is, despite the fact that age itself is a numeric field, or like an integer field, so we can infer this to be numeric. So we can say that it's int, let's say I32 or something like that, right? So for array group, we can infer that this is vector, but vector of what? Will it be vector of string, right? And we've got many array functions. Like we'll probably go to it, we'll see different stuff. Some aggregate, some group, some map, some filter. So some would change, some might just return the same kind of data. In the case of tags, let's say it's a vector of string, and when you do like array map, it might return a vector of a string. But what if you do like array count? Then that should give you an integer. So in that case, if we're gonna infer that, we cannot like naively, simplistically just say since you're using array, it's gonna be a vector field, because it's not the function type that you use that matters. It's what the function type returns, and these are all like SurrealDB functions that like you don't really have any type information from the language, right? So you need to write a lot more complex. I think like thinking through this thing, if you want to, of course, the initial version, the MVP could be very simple, right? With a lot more restriction, closer to what I was proposing now. But if you want to implement something very robust, it requires a lot more foreplan and thought and much more implementation that I think might even be a lot bigger than what we've implemented in terms of line of code. Probably well, you never know, but I can see this being like at least over, I think by now we probably have up to 100,000 lines of code, but that I can see that being up to like maybe 20,000 lines of code to reach a proper robustness. So I think that should be thought through a little bit more if we want the ergonomics around the infrastructure to be smooth. And because I don't want to go the route of the SQLX, and I love SQLX. I love what that's been done there, but that's not a trade-off that I think I'm happy to make. That I need to have a database running, cache some metadata locally, then I would work with the metadata locally, keep that in sync with the database. I tend to prefer code first approach, right? Let the code be the source of truth. I want my migrations, my database schema representation to come from my code, right? And when you have like this bi-directional stuff, that sometimes you need to get some stuff from the live database and sometimes you need to get it from the code, it leads to a lot of friction, in my opinion. So I like a one-way unidirectional flow, and preferably it should be from the code, right? And if you the trade-off or the downside to doing the code first approach is it requires a lot more planning and a lot more thought. So I guess I will still be thinking through this, and in the meantime, I'm just gonna probably leave this PR. I might close it for now, and implement the pick macro. I think the value proposition of this is quite clear, even though it might not be something you need if you really plan very well. But I can already justify the value proposition of this. Um, you have a user struct, but you need just two fields. You can pick it. The essence of that, you can type out a new struct with those fields. But the benefit of this is that you are actually keeping the two struct in sync. So let's say you have a user. I can actually just write the example here. Say we've got Ross. We've got a user. Actually, why not use my ID first? So what I'm referring to is, say we've got a struct called user, and we've got this bunch of fields, but we've also got ID, and ID is type, let's say unsigned integer, 64 bits or 128 bit, whatever. But we need, let's say we want to make a new user. In our case, actually, this library already solved this case, but I'm just This is more hypothetical example. We already solved this case with multiple approaches. You can do this. There, I have this macro called we've got a macro called object macro, but this object actually requires you to specify all the original field. In addition to that, we've got object partial. So with this, you can, if you say object partial user, I might actually have the example somewhere. Yeah. That's the implementation. So this is one use case. So basically, if you look at objects, we're referencing the original struct weapon, right? But if you look at weapon, for example, weapon has a few more fields. It's got 1, 2, 3, 4, 5 fields, but we're only interested in 2 fields, right? So object partial solves that case. You can specify just fewer fields than that. And we've also got this partial builder implemented. Yeah, so these are example use cases for weapon. Also, you see weapon, we've got like 5 fields, but with partial builder you can just specify fewer fields. In this case, we're specifying just 3: name, street, strength, and rocket, right? So we solved that case already, but I'm just trying to explain this, and especially when you're trying to do a select statement where you're trying to deserialize into an aggregated struct, and let's say from the user struct you need just 2 fields. So the second field is now called like user new or new user. So this is for deserialization, right? Obviously you can type out other fields, you don't need the ID here, but the problem is when we change this, you don't get an error, so there is no referential validation, right? So that's the value proposition of peak. When you do, let's say, peak, and I've been thinking about this API for a while now. So you could have something like peak. I don't know, you could use this. So let's say from user, that's the original struct. Then you put in the destination struct. You could call that new user. Of course, we can always generate the names ourselves. Then you say the field you want to pick. You can have that as list, or you can do, let's say you want to pick name, age, right? This is something closer to how I'm imagining the API. So the benefit of this is that you might say, why couldn't we just type this out? The benefit of this is that anytime you change something here, we're gonna get an error here. It's gonna tell us that, oh, name doesn't exist on user, right? So you know that something has changed, and you can imagine you might not really value this, but you can imagine when you have like this code base, for example, is probably over 1,000 lines. So like having to keep things in check might be a bit more cumbersome, and of course you're gonna get a runtime error. Ideally you should, but you don't want things like this to fail silently. The alternative to this approach, so this is more like an inheritance, like in spirit is closer to inheritance. But if you want to do this compositionally in Rust, the closer approach would be that you could do something like struct user data or user info, whatever. I don't know, or user location, whatever. User info, let's call this user info. Then we can pretty much put this here, and let's just comment that out. Then we can say user info, bam. Then we can use the Saturday attribute, done. And of course in that case we should also derive and this, and of course we would have to do the same here, right? This is a compositional stuff, because the benefit of this is that we are using the same struct here. So if we want to create a new struct, we can, for example, do new user, right? And we can do user blah blah blah. We can use a wrapper pattern, or we can just use a type alias. So we can do this, or we can just simply use a type alias if we're not planning to add an additional field. So in the type alias we can actually just do away with that. Oh, actually we still need that. Let's remove that, and we can just do this. But if we're gonna have an additional field, we can change this from tuple struct to a name struct. So we can change this and say user info, and then add additional field like something else and call that a string. Then of course you have to also flatten that. So if we take that, so these are the two different approaches. But the reason why having the pick macro might be somewhat beneficial is that when you've defined your field this way in let's say this is a table, it's a table in Surrey database. We say it's a table and the table is called user. It's called user. Let's put it here instead. And in this case now, we're coming this out. If we will start this way, this will all be field in the database, right? This will be a field of its own. So this will all be fields in the database. And you couldn't just, I'm sure I can implement that also, but you couldn't just go this way, because if you go this way, then it's going to be problematic. And now that I think of this, I might be able to support this, but it might just bring a little more complexity into the schema traits. It might bring a bit more complexity into that. But actually, now that I think of this, it might be possible, and this could turn out to be really helpful. So when I'm building the schema, I can just check if there's a flatten attribute, and if there's a flatten attribute, we seek the embedded struct and seek the field from within rather than using the current field. I can see how this might be really helpful. Yeah, this is something that might be worth looking into and supporting in my schema traits, and I need to give a bit more thought into, put a bit more thought into it to have something robust. Yeah, but so that's the value proposition of pick, in the sense that if you do pick, yeah, you want to pick these three fields. If we change something in the original struct, then we're gonna get an error, so we know this has changed. And in addition to that, we don't have to specify the type. We are inheriting the type from the referenced struct. So I can see pick being easy to, the implementation of pick is a lot more straightforward and easier to justify. And so the benefit of this is that if you've picked this as new user, then you can share this all around where you want to select your stuff. Yeah, and you can pick a single field. Like if you're going to be using the flatten approach, you're essentially changing your data structure in your code. And for every selection you want to do, you can't possibly be flattening every field, otherwise it's going to be a nightmare, right? Of course, it might help you maybe put a bit more like forethought into what you're building, but it might also be very nightmarish in the sense that you need to, if you have to flatten everything, create an embedded object for everything you want to select, then obviously that's problematic. So actually rethinking this makes pick macro a clearer winner. And you can think that, how are we going to achieve this? Because when you're introspecting, when you're taking this as a token stream, there is nowhere user provides like the field names and the types. And of course, it would be a different thing if we would want to allow something like, so we could take this approach, we do peak, then we surround it so that we can have access to the token stream. But of course, you don't want to be doing this, like this is not ergonomic, it's not feasible. For every peak you want to do, you can't possibly be surrounding the original struct. The other thing you can do is you can actually put this stuff here, and let's say you do peak, you call the name of the new user, then you put the field. So, but the problem with this, if you're gonna pick like, for everything you're gonna pick, let's say you want to pick like 20 stuff, then you have 20 lines here. Think about the combination. You can easily have like 100 lines, so that's also problematic. But I've been thinking about this a lot, and I already have an approach for this, which I'll be implementing in the other PR immediately I shut this. And there is another one that would be good, omit. So pick, basically pick the fields, omit, well, omit the field. And omit might be very valuable. Think about a situation whereby you have a struct with 100 fields, but you just need 99. If you would have to use pick, then you have to pick 99, and that's just like insane. In that case, omit would probably be better because you just want to omit the ID. But omit, with this approach I'm going with, omit might be a little bit challenging, a little bit more challenging. But yeah, I think it might be possible, but we can just do the pick first and see, we go from there. But right now, I think with the approach I have in mind, omit is gonna be an uphill battle, but we'll try anyway. So with these few points of mine, I think I will I'll leave this open for a while, but I'll probably be closing this. I'm not convinced that this is a valuable thing. So I think peak will be more valuable, considering that even when you're writing your select statement, you're already using a reference to the field names. So ideally, when something changes, you should get it anyway. But as I said, this initial version that I've fleshed out here, I might, if it's worth it, or like if the community votes for me implementing this, I could implement this. I think it shouldn't cost me more than 2 hours to implement this if I fully focus. Yeah. And even I'm seeing a new downside to this. For every time you want to select, if you have to write out this struct, then it's gonna be a nightmare. You have to do that for everything. So yep. Peak, I think peak and omit will be much more beneficial. So probably should shut this down, and I can, let's copy this into the peak PR or issue. So we've got peak here. Let's go. Yep. So I'm just gonna do that, and for now I will stash. I can actually just push this, some initial fiddling and third. Let's just and let's go back to master and main. Let's close everything. T vertical. Let's create a branch. Where's the best place to put these utility macros? Or should I put it in computer macros? I could put it here first. Or should I create a separate one? Maybe, I think this is different enough. Queries is not a derived thing. Computer macros. Maybe not yet. I could just put this macro. No, let's create curve in it. Need to think this through a little bit. Let's see, I've got historical person, name, nice. Person. This was actually improved quite a bit from many years ago. This is actually the approach similar to the approach I've been using. I've implemented for SurrealORM. Let's see. I like the direction this is going now. Yeah, I like the direction this is going. Yeah, I think this can be better. There is no need for this new struct. Or doesn't mean that you can use the same struct. But being able to reuse, I think, would be pretty cool. Yeah, it's at least it's way better than it used to be. Yeah, but I still wish a few things would be different, but definitely a good approach. Let me see if the migration is automatic. Oh, that's not database migration. I just want to see if it's implement automatically. Position schema in depth. I don't think it supports that. Yeah. I think the migration generating pure SQL is still, in my opinion, the most ergonomic approach, because you're able to see exactly what you want and you can add new queries to the generated migration. I just went through this. Okay. Okay. This feature would actually be good. It will unlock a lot of interesting patterns, but right now we don't have it. Let me subscribe to this issue. I should have subscribed to the previous one also. Okay, I'll come back to this, and can I still subscribe? Anyway, I'll come back to the complete. interested in this. Yep. Anyway, since we can't do that now, we will have to take another approach. So say something like this. Go. When I think about times we shared. It would have been nice to just do this, but so yeah, syntax is okay. Oh, I could have something like picked. Benefit of this is you'll be able to pick from multiple. So let's say this. Say pick. You'll be able to extend it. can do like view. You can even pick maybe from multiple. We can pick another person. I pick them. Alternatively, you can do struct survey. You want additional field? Yeah, you can use pretty much. Yep. I think I'll take a minute break and come back to finish this up. Thanks to everyone that joined, and I will be back right